Okay, this video is to show how could we use the data in Excel um, to plot graph in the Desmos. Okay, so in the last video we have a group of data for the basketball, and we plot the graph in the Excel, and in the Excel they give you the equation and also the um, the R square value. Okay, and we will see how the same group of data can get the graph in the Desmos. Okay, so first you need to copy all the data here in the Excel. Let's copy it. Right, so let's go to the Desmos. All right, and you just paste in that Desmos. So you see a curve right here. So these are the points of these are the points of the data. All right. Okay, but how could we find the equation of this group of data? Okay, so to find the equation, first we need to get the windows of the graph, which could serve us better. Okay, and we need to zoom in a little bit. Okay, that's too much. Okay, so sometimes you want to get the window exactly for your graph. You could do it in a more calibrated way by inputting the values for the range of x and range of y values. Here for your graph, we see that the range of x should be greater than 0 and less than 4, right? So let's do it like 0 for minus 0.2, okay, to 4. Okay, and for the y value, it seems like it's from 0 to 3. Okay, so we'll put it like minus 0.2 to 3.5. Okay, so now you see the graph is pretty much occupy the whole screen. Okay, and the next we are going to find the equation of such a graph. Okay, so if you want to see the line, you could click on that the green dot or any color. You want to change color, you can. Alright, and if you want to use line, you could use this one. Okay, and you could join them together. Okay, so that's your preference. Okay, so now I'm going to find a model for an equation for such a graph. So press atom here. So you use fx expression. Alright, so remember now the variables is in terms of x1 and y1, and you would like to use you must use xy and y1 to write the equation. Alright, so let's first use the general form of the equation. Okay, so let's y1 equal sorry, that's important, you should not use equals. Okay, so you should use another symbol. Okay, so you go to this keyboard of that Desmos and you press that ABC for the letters. So you see this a little bit curly things. Okay, so it's like a wave symbol. So that's Y1. Okay, so that's for modeling only. Okay, so how could we get the write the general equation? So that's A. So A is just a parameter. So you need to get a template for that general equation. So for x1, you need a bracket. Okay, and you need to get a square. For the square, you have to use the keyboard again, right? And plus bx1, okay, plus c. Okay, right. So after you got this model, you see that all the points fit quite perfectly into that the curve, and also they give you the values of r square, a, b, and c. So they give you values of all the parameters. Okay, so that's the equation they give you in the Desmos. Okay, let's compare this one with the one we've got in the Excel. So when we go back to the Excel, all right, let's look at the equation we've got. Okay, so again in the Excel is also a general form. Okay, so that's the equation in the general form. Okay, so how about the equation we've just got in the Desmos? Okay, so for A is minus 0.195826, okay, and B is 0.96863. Okay, so when you compare two values, you could see there's a little bit difference. They are not the same. Okay, I don't to be honest, I don't know why they are a little bit different. Possibly they use different program. Okay, I don't really understand this. Possibly due to the rounding off of the data. But anyway, so that would be a bit difference. But when you correct to two decimal places, possibly they will be the same. Okay, and how about, so one advantage of using Desmos over just using Excel is that if you use Desmos, you can use different forms for the quadratic equation. Okay, so here's the general form which the Excel will give you, but the Excel can only give you the general form. Okay, but in the Desmos actually you could use other forms as well. Okay, let's explore this the possibility. All right, so let's plus here another one. So this time I'm going to use the vertex form. Okay, so for the vertex form, okay, to save our time, possibly you can copy here. Okay, yeah, here. But this time I'm going to change that into a vector form, a vertex form. So x1 minus b, so that's the vertex form, right? And we don't have such term. Okay, so here's the vertex form. So you see, it gives you the same graph. That's the orange one, okay? But they give you different set of parameters. A is the same, but B and C, they're different, because right now B and C becomes the vertex of the quadratic graph, so that's why they're different. So actually, from the same set of data, you could get the form for the general form with three parameters all calculated, and also you can get the vertex form. Okay, again, they will calculate three parameters, and actually you could get the vertex from this form. Okay, so what would be the last form we've learned in quadratic equation? That would be the intercept form, the x-intercept form, or the factor form, right? So let's use that form. Okay, let me do it again. Okay. Right, so again, copy and paste, but I'm going to change that a little bit. I'm going to change that into the vertex form, and of course you have to okay, so the vertex form will be like so should be like this. So that would be the vertex form. So you see the same graph. Of course, they are coming from the same set of data, but this time you see A, B, C represent different strings. A is still the same, but B and C right now are representing the x-intercepts. Okay. Alright, so let's see. If you want to see the forms, okay, you want to see the whole curve, you could just make it smaller, and you can see the whole quadratic form. And of course, your data only represent parts of the curve. Okay, and in the Desmos, you have the three forms, and they give you the values for all the equations. Okay, so that's it. So you know that after you use Excel, you could also use Desmos, but the Desmos can give you more forms, more quadratic forms, but the values they got is a little bit different. Okay, and in the assignment you need to be aware of that. Okay, so the next video we are going to see how could we do it in an algebraic way by using a number of terms, and you could get the form. Alright, and we plot that graph into the Desmos to compare the form we've got with the form suggested by the Desmos. Alright, so that will be in our next video. See you next time.